Okay, welcome back. Okay, so we've had some questions asking about the sample code. Yes, absolutely, we're going to get this to you. We probably by I might even get it at lunchtime, so we're working on it. It's kind of a work in progress. I'm going to post it up onto OneDrive, and we're going to give you the URI so you can actually go and pull that down. So bear with us. We are in the process of getting it together, and yeah. While we're eating a sandwich or something, I might just finish that bit off, and we'll get that to you so you can see the sample code. Right, now this little nice little, can we have the clock please, Mr. Maestro? There, thank you so much. Okay, and this session is a shorter one, but it's very important. We're going to talk about page navigation and data binding in Windows Runtime apps. So this is talking about forward and backwards navigation, the role of the frame in all of this. We're going to start touching on topics that relate to app lifecycle, although a deep dive on that we're going to defer off until, I think it's session 5, something like that. Yeah, but then, so there's two topics in this, the navigating bit, and then there's the data binding. So they're not actually sort of directly connected, but they're obviously both important topics. Page navigation first. So we've created a single page app at the moment. Now, at a technical level, what you've got with a Windows Store app in general terms is that it sits within a window. Now, Windows 8.1 apps, big Windows apps, you can have more than one window now. So you couldn't do 8.0, but 8.1 they've added the ability to have more than one window for a store app. On Windows Phone, we've only got a single window, which is the whole display area, unsurprisingly. And inside that, you've got this thing called a frame. Most apps only have a single frame. Some of the SDK samples, they do wacky stuff with extra frames. But for the most part of us, you're only going to want a single frame, which sits again, is invisible, and it's another container that sits inside the whole area of the window. But the frame is important because that is the container for your actual pages. And the frame has also other interesting properties about it in that it tracks navigation between pages. So your pages obviously are also typically sized, nearly always, 100% time size. They are always sized 100% of your, let's get that right, they are always sized 100% of your display area. So the frame is created on app launch. So if you dig down into your app.xaml.cs or .vb or .cpp or whatever your poison is for your logic, you will find a method called onLaunched in a Windows Runtime XAML app, which has, this is your bootstrap code, and the first thing it does in there is it checks whether your window has currently got a frame on it. So the top line of that method you can see there where it says root frame equals window.current.content as frame. So if you're not familiar with C#, as frame means take whatever object is in window.current.content and try and cast it to a frame object. If it's not a frame object, you just give back a null, right? So then the next if statement says if root frame is equal to null, that means we haven't got a frame in our window, so we need to create one. So then we create one. We say root frame equals new frame. This is all boilerplate code. It's all in the new project templates. You will never have to code this yourself. And then drilling down a little bit more, there's a little bit more code that's where the ellipsis is for setting up that frame, which is a kind of boilerplate, start the app up kind of code. And then at the bottom, we have root frame.navigate type of main page and e.argument. So what this is doing is navigating to the first page that the user sees, which in this case is main page, an object called main page, which is what is defined by your main page.xaml file. And then you activate the window. So that's your boilerplate thing. Now, the frame is the container for these pages, so it not only navigates the first one, but it also keeps track as you move through different pages. So it maintains the navigation history. There's a property on frame called backstack, which returns a list of page stack entry objects. A page stack entry are the objects that encapsulates a movement, a forward navigation. It doesn't bother with backwards navigations, but a forward navigation through different pages in your app. So as you navigate between pages, obviously the onLaunched navigates to your first page there, and then as you do stuff, the user does stuff in your app, you're probably going to want to navigate. And a typical one there is where you show a list. Lists are coming up in the next module. And the user taps on an item in the list, so they've selected an item. So you get this like an item click event handler, or a item selected, or some kind of event handler associated with selecting an item. And you'll have some code in there where you would typically, if you think of a master detail kind of thing, you're going to navigate from your list page to a detail page. So here we've got a frame.navigate, which is the way that you navigate to a different page. It's from on any page in your app, you can call frame.navigate, type of, and then you just put the object type of the page where you want to go. This is different, of course, from Windows Phone Silverlight, for those Silverlight devs out there, where you navigate to a URI of a page. So this is one major difference between the two. And you pass some kind of an object. Well, optionally, you don't have to pass anything. But typically, if you're going to pass, you're going from a list where you selected an item in the list, you're navigating to a detail page, you need to tell that detail page what item it needs to show the details of. So you send the item ID in this example. So you're responsible for passing whatever parameters are needed for the app to make sense. This will just come naturally to you. You can navigate back. Now, this actually is not recommended UI, so you could put a large big button on a page, such as on second page there, which says navigate back to main page. And if the user taps on that button, you could have some logic on it. And this is the logic you would always use for navigating back. You always call if this.frame.can go back. So there's a property on the frame that says, hey frame, look in your navigation history and see if there actually is an older page, is there a page I can navigate back to? And if there is, do it. This.frame.go back. You always check, because there are ways you can launch arbitrarily in Windows Store apps, in Windows Phone apps, to any page from a tile, for example. There's other ways of launching apps, URI associations, and we'll talk about a lot of these through the Jumpstart, file associations, NFC launches. Anyway, there's loads of ways an app can be launched, and there could be unique experiences that launches to an arbitrary page. So there may not be a page to go back to, so always check. Now, what about this back button on the navigation bar, the hardware button, or if you've got a phone, one of these phones with soft controls, soft navigation bar, then it'll be a soft control, but nonetheless it'll always be there. The left-hand button on the bottom of the screen. If you tap back on that, what will happen? Well, actually, if the user's on page 2 of your app, they will expect your app to navigate back to page 1, the main page. But actually what will happen is it will close the app. It will suspend the app. It will actually go back. The default action for the hardware back key is to navigate back through the app history, not the page history within an app. So you actually got to put, and actually this is different from a Silverlight app actually, which it does actually in a Silverlight framework. The hardware back key causes a page backwards navigation. So this is different. So you've got to include in a Windows Store XAML app, you've got to include some code to do that navigation, to handle that, intercept that hardware back navigation, and tell the system not to do this navigate back through apps. You need to navigate back through the pages. Some of the templates with the new project got that in, and some haven't. We will explain what that is, the difference in a minute. So the new project templates, if you create a blank app, and the Contoso Cookbook I've created here was a blank app, doesn't have any hardware back key handling in it. So as soon as you add a second page, you need to add some more code to handle that. If you create an new app using one of the hub app or the pivot app templates, that does include hardware back key handling, the right sort of stuff. So you need to be aware of this. The kind of code you add to a blank app is like shown on the slide there, where you need to hook the back pressed event of your hardware buttons object. And in the event handler, you use code like that. Frame is, you get the window.current.content, get the frame. If it can go back, you call frame.goback. And then most importantly, you have to say e.handled equals true. So what you're doing is you're telling the shell, don't worry, I've sorted this out. If you don't set e.handled equals true, the kind of default behavior of navigating out of your app, suspending your app will happen. Sometimes you want to override not on an app level, like in app.xaml.cs, like we just showed there, but in most apps that's probably going to be what you want. But you may have occasions where you need to have specific back key handling on a page. You can do that. You can hook the back pressed event on a page. Here we've got an example of hooking it in the onNavigated to event, unhooking it again on the onNavigated from event, And then there's your event handler in there. So why might you want to do this and not have a page backwards navigation? Well, maybe that page is showing some transit UI. Maybe it's got a pop-up showing. And actually the logical thing for the user, what the user would expect is when they hit back, it will throw away that transit UI and go back to the original rendering of that page. So that's why you might want to do that. So let's have a quick look at that. Back to my system, which hasn't logged out. Woohoo! We can go to, let me find my notes. Okay, so it's a very simple one. Page navigation begin. This is our Contosa cookbook. Again, here's my page. It's the one we created before. We've actually got, we've already got an app bar on there. I want to add a secondary command to it. At the moment, the app bar, we've got an app bar button on there with a flyout. We've got a nice little flyout with some ingredients lists. I didn't show you that actually. Let's show you that first. We run this on the emulator. And this is the same app before, but we've got this app bar on it very easily, and that shows the ingredients. This is a flyout, which I said it's soft. You know, you can actually interact with it and tap on it and that sort of thing. But it's soft. Soft dismiss. So as soon as you tap outside it, it disappears. There's nothing at the moment on the secondary app bar, secondary thing. So let's just go and do that. So one nice way of doing this. This is a window called the document outline, where you can actually drill right down into all the controls on that you've created on, and you can set properties and do stuff in here as well. You can also in your command bar, we can add commands right from here. So I can add an app bar button in my secondary commands, and here's my secondary. Let's put an about page into this app. So we go about. You could actually set an icon on it. It would be ignored, but if you were doing, you wanted to cut and paste, these are all the icons. Just to give you a flavor, all the built-in icons that are available to you. Masses of them, which is really nice because we didn't have that many on Windows Phone 8 Silverlight, but loads and loads and loads of icons, and of course you can create custom ones as well. But anyway, on phone, this is simply wouldn't matter if you specified it, but it's going to be ignored anyway, so I'm not going to do that. And then we're going to put I need to put an event handler on it, so you can do that in a number of ways. I can do it from the properties window. That's put a click event handler on there. And then I'm going to add an existing item. I've already got a pre-built page, so I'm going to add an existing item to this. We go up, and the demos. Where's my items? There we go. Here's my about page. I can add that to my project. So we've added that into it, and now I can go frame.navigate to a type of whatever the type is that we want to navigate to, and that actually is the about page, which we just added. Doesn't need any parameters. We're not passing any navigation arguments to it, but now we'll have a nice little about page. Now, so there we are. There's my about page, which actually has some. Typically, you'd put a bit more information on it than that, but at least that's a good start. Now, what's going to happen when I hit the back button? Would you like to hazard a guess?
Is it going to go back?
Yeah, but go back right out of the app. That's what's going to happen. It suspends the app because we've got no back key handling in this at the moment. So we actually need to fix that. So one way you could fix it is to do the navigation handler. I'll do that in a moment. But the kind of easy way of doing it is just to add that code in that we showed before, which is we go hardware buttons, which I'm going to need to fix up the reference for that, which is using windows.phone.ui.input. And there are loads of hardware buttons. There's actually ones for the camera button as well, as you can see there. But we're going to just hook this guy, create an event handler, and then this is where you put your logic. You say we're going to want to get a reference to the frame, so we go root frame is equal to window dot current dot content as frame. So we're checking we've got a frame, which we surely should have, and then we say if the root frame is not null, That's the first check. And also, if that is true, so if the root frame is not null, then root frame dot can go back. Then we say, okay, good. Then we can actually enter. We go frame dot go back. Call the go back. No, hang on. Root frame dot go back. Sorry. Root frame dot go back. And now, and don't forget, most important, e.handled equals true, otherwise it won't work. And we will go to check that works out, which it should do. We go to our about page, there we go, and then we go back, and yes, we got, and look at the nice, hey, another thing, you get nice page animations, all you Silverlight developers, for free. Yeah. Look at that, you have to add that in a Silverlight app. Nice, cool stuff you get for free in the Windows XAML runtime apps. Just before I leave this, if you wanted to, the easy way to add the default, the navigation helper, which I'm going to talk about in a minute, so this is a preview. You can add an existing item to a project that hasn't got navigation key handling in it. Add a new item, sorry. If you add a page of type of basic page, it will put a pop-up and it says, this needs some other files. Can we add them? You'd always say yes. And it will stick into your project a bunch of files called Navigation Helper, Observable Dictionary, README, and Relay Command, which are useful on Suspension Manager. We're going to talk a lot about these over the next couple of modules, particularly Navigation Helper in just a minute. But that's just to show you how you can easily add it. I mean, I've got a page. You can almost do that. If you want those classes and don't want the page, you can add the page and then delete the page again. You've still got the kind of utility classes, so that's a nice way of adding them in. So, why did I show you that? Well, I'll talk about a couple of things. Page cache mode first. There's this thing about a page, this is just really, don't worry about this, just so you're aware of it, is that when you navigate forward to a page, obviously the first time your app does that, you're going to create a new instance of that page. And then you might navigate to another page and then go back to it, and then you'll do another forward navigation to the page of the same type. This navigation cache mode simply controls whether you just reuse the same instance of the page object you created before, which is .navigation cache mode.required, which is actually set into all the new project templates. That's kind of the de facto standard for phone projects. Or if it's navigation cache mode.disabled, then you will always get a new instance. It will just always blow away the old one. You get a new instance always all the time. But there's kind of obviously a slight performance implication of that, which is why I think the new project template set required by default. And then there's this enabled one, which is kind of required, but there's also limited by this frame.cache size property. Don't worry about it. It just means that you do have to, I'll show you why it makes a difference. It means you have to manage the state yourself. So if you navigate forward to a page and you get the same instance back, it will have the same values in the controls that when last time you left it. So it does mean you just have to write the correct code to reset the state on a page if you've got required. So this is kind of what we're going to be talking about more in the application lifecycle session in session 5. But what you are going to do is save and restore page state on navigation. So if you want to go forwards to a page and then you go to some other page and then you obviously go back, you'll probably would expect page 2 to look the same as you left it, probably. With navigation cache mode disabled, you'll get a whole new instance when you navigation back, so that won't be the case. This is why you need to care about this. But with navigation cache mode enabled or required, you'll get the same instance and that will just work. And like I said, required is the kind of de facto standard anyway. But you need to be aware of this, and this whole state, what the page looks like when the user navigates to it, does make a difference. The way that you handle that, there's two methods called onNavigated_to and onNavigated_from, where you put the code to handle this. And I'll show you a bit of an example in a minute. I showed you this. This is how you can get the navigation helper, which helps you with all of this sort of thing. So let's just go off to that and show an example of this. So this is a new one where the I've got my on navigate. Let's just show you it running first. This app is got a main page which just has a button on it, and you go to page 2. And this one we could actually put some values in, so we can go, ooh, hello, world, just to be unoriginal. And you can set a radio button. So I'm going to set radio button 2, and then you can go to page 3, and then we go back, and it's all set. You've got the same values, and that's good. And then we go back, and you can go forwards again, and it's still set like that. Now, you might imagine that should be empty because we've done a forward navigation. Depends on the app. This is a very simple example, but the app scenario is that you should expect that page to have been reinitialized at that point. Why did all that happen? Well, I've got this sample has got this navigation helper in it. Navigation helper has all of this stuff. It's got loads of comments in that tells you how to use it, but it's got all of the hardware buttons, backpress stuff wired into it, so you don't have to worry about it. So all you need to do is have your pages wired up to it, and all of these pages have been set up to do that. The way that you do it is you basically have a class member of it, and those comments in Navigation Helper tell you how to do this. And this is when you add a basic page, this is how it's set up. There's that navigation cache mode required, and this is where it wires up a couple of Navigation Helper events on it, load state and save state. And basically the idea is that on save state, when you're leaving the page, you will save state associated with the page, transient state. It's like what the user has put into controls, what data they've entered but haven't saved yet. This becomes really important when we start looking at the life cycle and stuff that's been terminated. But I don't want to talk about that now. And then load state is used to load stuff back in. But you might want to, this state object, the important thing about the navigation helper, so you wire it in by simply in onNavigated2, you call this.navigationhelper.onNavigated2 method, and in onNavigatedFrom you call this.navigationhelper.onNavigatedFrom. And this is the process by which you wire your page into the navigation helper, and you get that back key handling for free. So that's kind of a quick introduction to the navigation helper. We're definitely going to come back to that, and you'll see how that works when we get to the page lifecycle session. Okay, a very important topic, and I haven't got a lot of time to talk about it, so this is going to be a challenge. Data binding. So, you know, in our Contosa cookbook, we started off by we had that ridiculous text block where we put all the instructions into it, this big long bit of text. And of course you can do that in XAML, you can do that in code, but that's kind of unwieldy, and it's not the way you're going to build a professional app. So what you need to do, because if you start doing that, you're going to soon end up with massively complex code, and the app is unmaintainable, and it will be error prone. You can't do that. So you need to use data binding is a much, much better way of doing that. What you need to do is create a class which has a special purpose. We call these classes view models. So this class exposes properties on it. And in its simplest, what you do is the display properties and display controls and input controls on your page. Use this thing called XAML data binding to bind to those properties so that when the user interacts with the page, they see the values of the properties that are exposed by that view model displayed, and when they enter text, like clicking a radio button or selecting an item in a list or doing anything like that, or entering stuff into a text box, then those changes are automatically sent back to the view model. So this is a binding statement. So instead of having text equals 14 lines of text, like we had in the directions for building our recipe, instead you bind to a property on a class called directions. This statement doesn't say what the object is where that directions property can be found. The way that is defined is by a different property called data context, which you can set on any control, but typically you'll set that on the page of the page control. There are data binding modes. The default is one way, which means whenever the property, your logic, changes the values exposed by the properties in your view model class, your UI will automatically update. One time is a variant on that, which means just when the page first renders, go and get those values, but thereafter don't track any changes in the view model properties. One way it means track the values in the ViewModel properties, and two-way means that when the user enters something into like a text box, that's written back to the underlying ViewModel. The beauty of all of this is that this is all done in XAML data binding statements. Your ViewModel object doesn't know anything about the view, the XAML page. It's a nicely decoupling. It ends up with much neater and cleaner code. How does a data binding, how does a view manage to get alerted that a property has been updated in your ViewModel by some background logic, or by some logic you're running in a task, or you've gone off to get some data from the web and you've updated your ViewModel? The way that a ViewModel does that is it's very simple. There's nothing magic about this. It's just firing an event whenever a property changes, and that event is called PropertyChanged. That behavior is encapsulated in this interface called INotify PropertyChanged. So that INotify PropertyChanged interface simply says any class that implements this must have a PropertyChanged event. What happens is the view actually subscribes to that event and gets notified, and whenever that event fires, it will go off to the ViewModel and find out what has changed. So this is what it looks like. Here's my the view actually subscribes to the PropertyChanged event, and so whenever anything changes, like property A or property B, then like property A has changed here, it fires the PropertyChanged event. The view will get that because it's subscribed to the event, and it will go off and pull the new value of property A from your ViewModel and update the UI. That's in simplicity what it is. Now the way that you do this is you need to instrument your setters. So here's a public property called ID, and you'll notice that in the setter, whenever that value changes, we call a method called notify PropertyChanged ID, which fires that PropertyChanged event, and it gives the name of that property. This is the old way of doing it. It's kind of error-prone because this is what we call an example using magic strings. If you ever use the nice refactoring tools and change the name of that property, which it will nicely do throughout your app, what it will not do is change that hard-coded string in there to the new name of your property. So you have to do that manually. This is a cause of great frustration to XAML-based developers for a good long time. So the new way of doing it is to use this rather wacky thing called the caller member name attribute. This is the way you do it. The logic from the middle of the page down there, the property change logic, that's kind of boilerplate logic. And typically you put that in a base class, and then you inherit from that base class from your actual view model. It has the same effect. It fires the property changed event whenever the setter changes. It just automatically gets the value of the property that's calling it and throws that out as to the consumer. So you don't have this magic strings problem. Lists can bind to collections of objects in the same way. You have this item source equals property, but you will set that to a collection of objects rather than so an item view data context is like a single object. Item source is a collection of objects. So that's for lists. We're going to talk about that in the next session. So this is an example of an observable collection of objects. We've got a few data binding improvements in XAML. So target null value, so you can bind to a different property if the source property, the main one you're binding to, returns a null value, or you can specify a fallback value to use instead. This whole thing I've been talking about, this data binding, actually is the most important ingredient of a wider pattern called MVVM, which I'm not going to dive into now because frankly you'd need a whole day for it. But this is the kind of cornerstone, the foundation of MVVM, where you have strict separation of concerns. We have the M is model, which is your data. VM, of course, is your view models, and view are your XAML pages, and it's an architectural pattern that is a good way of organizing your Windows Store apps. Very quickly, I'm going to show you a sort of before and after demo because I'm kind of out of time. So you've already seen the before version before. So I'm just going to simply switch to the data binding end one and run it. And this one works just the same as before, but has some very important differences. There's our French macaroons, and it's got our nice ingredients in there. But if you dig into the way that has worked, is our main page now has got a lot of binding statements in it. Let's go and find them. Here we've got our header is bound to the text that show in the header is bound to a property called short title, and the down in here we've got the directions is bound to a property called directions. The prep time is to prep time. So you get the idea. So we've removed that hard coding in there. Where is that object? I've now added into this project something called the recipe data source, which if you dig down into it, we've got some classes called a recipe data item. Here's a recipe data item which has a bunch of properties on it. This is the view model, prep time, directions, which has got the data in it. The data actually comes from a JSON file, and we are simply going to in the logic for this on the onNavigated 2, we simply call a method on recipe data source called getItem, which returns a single recipe data item object, which is this guy, and we're going to set that as the data context of our page. And that's how the magic works. We've removed all that hard coding. All right, I'm going to stop at that point. That's a very quick, too short introduction to data binding, but we're going to use this all the time now, data binding, for all the remaining samples. It's the only way to build these apps.
Yeah, we're going to see a lot of it in the next session.
Okay, so we'll be back in a few minutes, and Matthias is thankfully going to take over. And I can thank Lord for that. And I'm going to, he's going to run you through programming the list controls.
Yep.
See you in a minute.